Hi. I am a maker. I like building stuff. I like fabricating things. And I believe that if we can have people make stuff that they want to make for themselves, do personal projects, give them the tools to make whatever they want to make, we can make this world a little bit better, a little bit more fun. And we can do the same for education. So making on your own is very cool. It's a very rewarding and very challenging thing to be able to make whatever you want to make on your own. But I know that making together with others is even more fun, and there's lots of stuff that you can't even make on your own. To talk to you about a little personal project of mine, I'm actually working together with my wonderful wife, who's sitting in the audience there, and we're trying to create a little copy of us, which is growing in her right now. I wasn't able to do that myself. So us makers, us people who have ideas and who want to create stuff, we need spaces. Hacker spaces, maker spaces, 100K garages, or in my case, Fab Labs, which is short for Fabrication Laboratory, for the people who didn't know. So what I want to talk about today to you is what Fab Labs are, what the network of Fab Labs are. What are they going to change into, what it means for the future, and what it means for the way we can do education and the way we live our life. So if I have to do that in one sentence, I would tell you that Fab Labs are a network of interconnected spaces with computer-controlled machines that can make almost anything. And I'll get to the almost. So this is a bit of a long sentence, so let me elaborate and break that sentence up for you. And I'll start by talking about the machines we have, so those digital fabrication machines. And every Fab Lab has one or more of the same set of machines, so we can all make the same stuff. So one of the machines we have, it's the most high precision, is a little 3-axis milling machine. So it's a rotating tool. You put in material like this block of wax, and then you take out what you don't want, and then you have a mold. In this case, to make a mold to make personalized chocolate tablets. So we teach this to people. It's very easy. What we can also do is make components for bigger projects. So we can make like a circuit board, like in here, in this little speaker, by putting in copper-clad board, machining away what we don't want, and we can solder on the components. So another machine we have in most Fab Labs is a vinyl cutter, which is basically, again, a computer-controlled tool with a little rotating blade, which allows us to cut vinyl and different materials to make stickers, like the ones here on the whiteboard, or T-shirts, or we can even cut very thin copper foil that allows us to do flexible circuits. So if you need conductive threads on something that is not straight, but maybe a curved surface, you can still make conductive threads on there. The most popular machine in Fab Labs by far is a laser cutter. And you can imagine a laser cutter by just thinking of a machine that's able to saw through flat materials, but it's not using a saw, it's just using a laser to burn through the material. So an example of what we can make with a laser cutter are these letters. We cut 2D pieces, we put them together, we have 3D shapes. Another example that's really nice is this Hoberman sphere here. This is about 1,600 laser-cut pieces of wood. We put them together by friction, and now it's actually a sphere that can fold and unfold, which is pretty cool for education. You should see all the mathematics professors that come into our lab. They go crazy about this. Another thing you can make, and we now know that actually with a Fab Lab, we can make another Fab Lab. But to be more precise, you can use a laser cutter to cut pieces of wood and put together this little 3D printer here, which uses a little bit of a different technique than all the other machines. We don't do subtractive machining. We don't put in material, remove what we want, and have the object. We actually just have a 3D file of something, and then the machine will deposit layer by layer, the plastic in this case, until you have the object, which can be a useful object like this, or maybe a cup to drink from. And I even tried to make a little copy of myself, but it turns out I really need my wife. It's just, I'm not as good as that alone. So the last machine we see in many Fab Labs, and We see it more and more as a big milling machine. So it's like the little milling machine, you put in material, you cut away what you don't want with a rotating cutter, and you end up with the product. And you can put stuff together, so you can make this chair. You can also make stuff in 3D, so these are the mountains we're currently in, the Chartreuse range. For everyone who's not from here, go and hike. So we can make big things, and I would say all of you should Google Fablab house after we're done here, and you'll see that there's a wonderful house being built with the exact same machine I used to make this chair in Barcelona. It's a very fabulous project. And you can actually download the files for the house, and you can come here to our science center, like Casemate here in Grenoble, use our machine and make the same house. So on that, Fablabs are not just a series of machines, they're also a network. To talk about this chair a little bit more, I'm sitting on this thing about every day when I work, but I didn't meet the designer until last week in Japan when we all got together for the Fablab conferences. He's called Yens Divac, and he considered all the Fablabs as his workspace, and since they are all over the globe right now, he has a workshop all over the globe with the same set of tools, so he can do the same things. So he came up with the design for his chair, and he just emailed me the design because I thought it was a nice chair, and I could make his design. So he traveled all over the globe, but this chair traveled a lot more than he did, and we can find it everywhere in Fablabs now, personalized a little bit different than his original design, because we no longer need to send a product or send a material. We could just send an email with the digital file, and then we can make the same thing, because we all have the same tools and the same processes. Another example of this is the Fab Lab in Jalalabad in Afghanistan. They wanted to increase their Wi-Fi range. So they're using standard Wi-Fi routers like the ones we have here in this hall, who have a range of about 200 to 300 meters, which was not enough because they wanted to share their network with the hospital next to their Fab Lab. So they created low-cost antennas that you can make everywhere with simple tools, and now they can send their information 2 to 3 kilometers instead of those 200 to 300 meters. And this project got picked up by people in Nairobi, in Kenya, who said, we can use that too. Actually, we can start a business with that. So no one shipped an antenna or material to Nairobi. They just send an email with the files, and they could make the same thing. Jens, he traveled through all the Fab Labs, and he came up with a lot of different things to make, and he actually educated a lot of people in the other Fab Labs to make the same stuff. We educate each other to learn how to use the machines and how to use the processes. So let me return to more locally here in Grenoble. What do we do here in our science center in the Fab Lab? Well, we do both formal and informal education. Informal education, and I'll just give you one example, but we do a lot more things, could be this little speaker. What we do is workshops in which we teach adults, children, young adults, to make something. And people can either come up with their own project, which obviously interests them, so we don't need to interest them, or they can pick one of the projects we came up with for them, like this little speaker. And in this little speaker, as I said, there's a little circuit, so they have to solder the electronic components on the circuit. And while they are doing this, we're teaching them about electronics. We can teach them what a resistor does, what an op-amp does. And they get interested in it. They get interested in how electronics work because they immediately see the use of that. The use of it is making a laser-cut box to put a speaker in and then 3D print a knob and turn up the volume so you can really annoy your parents with your music. So as I said, we do multiple workshops like this, and we always try to put in a little bit of education and to learn people about stuff by building things that they want to build themselves. So they immediately see the need to acquire this information. We call this just-in-time learning instead of just-in-case learning, which we do in most universities and schools. We teach people enormous amounts of things just in case they might need it in the future. In Fab Labs, we do projects, often very personal projects. People make what they want to make, and we teach them what they need to know to finish their project. So that's the informal education part. We're also in formal education. At a certain point, we said, wait, if we have all those Fab Labs everywhere in the world and we're now all connected by email or video conference, be it Skype or Google Hangout or the video conference that the MIT, where the Fab Labs came from, put in place, we can communicate and we can work together with the same tools. Can we create a global university? And it turns out we can. We now have what we call the Fab Academy. And you can actually get a diploma from the MIT in Boston without ever going to Boston. You can get it here in Grenoble with us, or in Barcelona, or in Amsterdam, or in Nairobi, or in the backcountry of New Zealand with Wendy Neal as a fantastic Fab manager there. And what will happen is that you'll get stuff to do, homework, via video conference from professors, genius people from all over the globe. But these things are not imposed on you. We just tell you something like, make something big. And students come up with the most crazy things, but they learn a hell of a lot in the process. And they actually learn a lot from each other too. There's always local people, here it's me, that help you with your homework. You do what you need to do, and then you present your homework, again via video conference, to the professors all over the world. And if you work hard, then in 5 months, you can actually get a diploma from the MIT that teaches you how to make almost anything. And let me get to the almost. Actually, let me make a parallel between computing and fabricating, between making and calculating. When we started out doing computing, we had these huge machines that needed a room, and that were not very powerful, difficult to use, slow, not very precise. And these computers, they got smaller and smaller until they fitted in a closet, and that's when we invented Unix. And they got smaller and smaller still until you even get a computer for Christmas at your home. And for the geeks back then, the people like me back then, it was fantastic. But it just had switches and you flipped them, and at the end you had LEDs that either went on or off or they blinked to show the result of your computation. But the technique was the same. And again, computers got smaller and more powerful and faster, and we've seen before, now we all have supercomputers in our pockets, and they will continue to get smaller all the time. So if I make the parallel, it would be that Fab Labs are those computers that you could get for Christmas. They are the first little tools that allow us to make almost anything, but they are evolving, and we're actually, as I said, building machines with the tools we have now who are getting better than what we started out with. And we can imagine new tools like assemblers who don't have the problem that 3D printers have of error correction. And we can think about things like folding and smart materials, because Fab Labs give us these tools and give us the means to educate globally and thus to tap into a much larger portion of this planet's brainpower. Because I think we've seen today, with all the wonderful speakers here, that there's creativity anywhere, there's knowledge anywhere, and we just need to give people the possibility to share this and the tools to make whatever they think they need to solve the problems to create a little bit of a better world. So I think that Fab Labs will eventually turn into maybe what the Star Trek replicator is, and eventually we'll all have those in our homes and we'll truly be able to make anything, and we'll remove the almost. So what I would like to ask all of you, when you go home tonight or maybe back to school or to work on Monday, is to ask yourself the question, if I could make anything, what would I make? And could I make something that is not only nice for me, but also for the people around me? And maybe here more interesting, could I make something that would make education better? Because I believe if we embrace all those wonderful tools, these means of communication, and all the ideas that got shared here today, together we can actually create a wonderful new system of education, and my unborn son will have a better education than we have now. And on top of that, we'll together create a world that is better than now. So thank you.